to this computer. All right, we're recording. And so let me get that file open and then we can go from there. So
I like the tiny print that you have included.
where was that?
It's slide 4 on the PDF of sample prints.
All right. So let me find. I'm trying to remember where I saved my PDF of my sample prints here. So print examples, maybe part 1. Yeah. Okay. So so slide 4. Let me see if we're if we're talking about the same thing. Let me start and I'll drop this down so I can share this screen. And I
At
know
least in the browser, it's small.
You guys can't see what I'm seeing yet, but okay. So let me see, share screen 2, share. All right. So you guys are here for our example prints. Yep. Everybody sees that?
Yep, got it.
Yes.
Okay. So sweet. The other thing I want to do is, let me see, open up another version of SolidWorks. So what I did is, and this might take a little bit of jostling things around, but I found 3D models for all of these. So so all of these prints weren't just straight prints from the internet. There's 3D models for all of them. So I can show you guys what they look like and we can kind of spin them around and get a look at them. So here, if I just go. All right.
Yeah, for whatever reason, the PDF view in the browser, the print for that what looks like a pump valve.
Yep.
Is like super small.
Oh, this one here?
Yeah, that one.
Okay. Interesting. Am I zoomed
normal size on your end, but like it's super tiny in the browser view.
Weird. Huh. Yeah, I don't know. I just honestly, I kind of assumed you guys would just open them up in Adobe, like Adobe Reader. And I don't know if maybe they show up a little bit better there or not. So hopefully it was at least readable. Or legible. This is that piece right here. I don't know if I've actually got a 3D model for that one that we can zoom around. But the first piece we have, let me go here and open. And so let me see. So that is, leave this model here. So I'm just gonna drop this down. So this program is called SolidWorks. I think we looked at it a little bit. It's what I was using to build the 2D models of stuff. So let me see here if there's probably not going to be a great way where we can view both at the same time. So I think what we'll do is we'll just end up switching back and forth a little bit between the PDF and the 3D model. But the nice thing about this is then, we can look at it from whatever angle we want. So I know that some of you guys were discussing how it was kind of hard to look at a print, especially if you didn't have this version of it and tell what you were looking at. So I thought if I made you guys some prints, obviously the dimensions on this are tiny. I will admit that I was super lazy because these were example prints. I just did the auto populate on the dimensions, which is why they are way overly, that's packed in there. But since this is just kind of an example of what your views are going to look like, it's not super important to what the dimensions are unless you actually wanted to make this table. That being said, this is pretty much inclusive of every dimension from this angle and every dimension from this angle. When it auto populates, it makes sure everything is in there. So, but anyway, this is this table here, and if we look at it in SolidWorks, so you can see there's some callouts for welding as well, but this lets you, so you can see here, and so that first view, this view right here is going to be, let me see if I can do this quickly. View orientation, top down. So it's going to be this view here. I think it's rotated maybe 90 degrees, but essentially it's this view right here. So you're looking straight down at this table. And that's what you see here. So it is rotated 90 degrees, but you can kind of get the right, rough idea here. So that's that view of that table. The next view, and I'm bouncing back and forth a little bit. So this is the front view. So the next view would be, and if you see that, so when I click on this, you can kind of get an idea here. So I can spin this around and I can click on the face that I'm going to be looking at and see. So that was the top down view of the first one. If I click on this face here, this gives us that front end view, right? And so that's this view right here. Does everybody see that? And then if we go back into here, we'll zoom out a little bit and we can then go to, so if I spin it isometric again, we're going to look at it through this face. So straight on from this side, and that's this view right here, which is that view right there. Does that make sense to everybody?
Yeah.
Oh, yeah.
So for our final project, are we just doing like turning the picture like that into what that is right there?
Yeah. So essentially what you're going to
Just
do
that.
is you're going to recreate this. You don't have to draw the isometric view.
Are we gonna do dimensions and stuff, or?
I will have you guys do some dimensions. Like I said, it is super simple though. So let me make sure I don't have any participants waiting. No. Okay. Here I can actually show you what I'm going to have you guys do real quick, just so that you have an idea in your head right off the bat of how complicated I'm talking. This is the piece I'm going to have you guys draw.
Okay.
It's made up of two pieces. It has two welds on it and a little bit of dimensions. So basically what you guys will get, and I'll show you how to do this, is I saved this as a 3-dimensional object that you can open up in a free piece of software. If there for whatever reason you guys aren't able to get that software, we can figure that out. And I will figure out a different way of opening it up, or taking multiple screenshots and giving it to you so you can see all the different angles and dimensions. So essentially I want you to take this and turn it into essentially these 3 images, which should be pretty straightforward and should be pretty easy. And like I said, should be relatively quick. So even with a ruler and even if you don't have a compass, something round to draw the circle with, you should be able to knock that out pretty quick. So that's my hope. The idea is though, is that you can take a 3-dimensional object and turn it into a print drawing. Because if you can go that route, then you can go the other route. And we've already shown that you can, you looked at these and you defined the call outs. It's a lot harder for me to give you a 2-dimensional drawing and say, hey, draw me a 3-dimensional image. This takes at least a little bit of drawing skill with perspective and things like that. The beauty of blueprints is you eliminate all the perspective side of drawing. It's all just flat 2D drawing for the most part. So a lot easier for you guys to replicate something like that. All right, so we're gonna go on to the next one. So this is another example of what a blueprint might look like if you had something that you were designing and building. And you'll notice in here that you don't have those standard drawings, right? So what you have is you have a front-on view, an isometric view, and then you have views of kind of the complicated parts. And that piece is, if I go here and go open. That's this right here, right? The only difference with this 3D model is it includes 3 support structures in there. Essentially, so if you were designing this, you could pull out whichever one was going to be your front support. They basically just made this as a Lego block piece, so it can be deleted out of there. But so if we look at this, drawing, we can see, you know, we have our supports here, here, and here, showing, you know, what size bolts you're using, your spacing, things like that. And then if you look at that Solidworks drawing, you know, the model, we can zoom in on this and we can see, you know, we can see how those are represented there. I think this one's pretty easy to visualize. If you were looking at this, this isn't something necessarily that's hard to visualize, because each one of these are pretty distinct on what they're showing. You know, this is the most obscure piece, and you know, it's essentially, you can look over here and you can see where they're doing their call outs for everything. So this piece is basically just a side view here, showing this with the bolt patterns going through. Does that make sense to everybody on this one? Like I said, I think this one was a little bit easier and a little bit more intuitive to what it is.
Yeah.
All right, this is just another table. Pretty simple, a little bit more bolted together, not so much welded. But once again, top-down view, side view, end view, right? And so if we look at that one in SolidWorks, it's going to be kind of this very similar to the first view that we did. Let me see, where are you at? I think it's this one. Waiting patiently. Actually, so that was one we already had open, or we froze it. I might have froze it, made it think too much. Yeah, it actually tried to open that up in Adobe. I don't know why. So SolidWorks has encountered a problem and needs to close. So that's what it's doing right now. Sorry about that. I had about 6 models open, so I'm not horribly surprised. Just asked it to do a little bit too much today. Plus, I think I'm recording this video and I've got 2 video editors open right now too. So I think I might be asking my computer a little too much. But this one's pretty straightforward. Let's go on. We can just open up this next one. I think I've got a 3D view of this. I tried to make sure I had 3D models of everything that I was going to have, so that you guys, if you had questions, you could see it in that view. Waiting. Any questions that you guys came up with other than text size being absolutely tiny on one of these? When you were going through these?
It was only tiny in the browser view. I opened it up in
That one
Adobe
you were
and
just showing.
What was that? I got two conversations there. So only tiny in the browser view. What was the other comment?
The part that you were just showing, that pump valve.
Uh-huh.
That would be, all those call outs would just be for like actually cutting the pipes, not actually welding them together, right? Like, because they're all separate parts.
There is actually some welding on this. So I think this is that part. Yeah. So this is that
Okay.
part here.
Yeah, I know there
So-
would be welding on it, but I wasn't sure. I'm not sure if I saw any on the actual blueprint.
Let me look. They've got the symbols for it. But I do believe you're right. I think that this would probably be, let me see, I scrolled down, assuming that there was a bottom part to that page. There isn't. I would assume probably it's just a standard weld that they're requiring for each one of these. You know, like a certain size bead. I don't see an actual weld call out on any of these either. Yeah, so it's just all pipe dimensions. So whether or not it's machining or stock pieces,
Yeah.
and then you know what your cuts need to be so that they mount well together. And then it shows the weld beads, but it doesn't actually have the call outs for the weld beads.
So like this print right here would be separate to what a welder would see. Like this would be somebody machining all these pieces, and then later a welder would come through and have a separate print with all of his call outs on where to set those certain dimensions of weld profiles and whatever design weld it is.
Yes, potentially either that, or it would say, though I'm looking at this, it does look like we have different size beads. I was going to say either that, or it would say, you know, all welds are, you know, 1/4 inch fillet, you know, welds unless otherwise noted. And then that could just be on this print. And so
Yeah.
a welder could look at this and be like, all right, and you know, we have all these pieces. And then I can, you know, you can look at this and see, you know, each one of your pieces is numbered. And
Mhm.
so you could put it together and where everything's supposed to be.
Okay.
Though I would think that perhaps you would have maybe an isometric view that that showed those, you know, showed it a little bit better together. This one is definitely one of the ones that's a little bit more confusing because it has got a lot of stuff going on. And you can see that, you know, in here, depending on how you look at this, there is, you know, there's a lot of features to this, but you can also see where having an isometric view on a print, even though they're really hard to draw by hand. So back in the day when everything was, you know, by hand drawing prints, you know, or even much more difficult for computer editing and creating for prints, you might not end up with something like this on a print. But now, you know, CAD programs have gotten to the point where you know, you can pop this out with your, you know, 3 or 4 other different dimensional drawings, and then be able to give the person who's assembling this a lot more of a intuitive view of what, you know, what they're creating.
Mhm.
yeah, the machinist wouldn't necessarily need to know what weld goes where.
Exactly. So you might, you know, unless this was something that just went to a fab shop and your machinist is your welder, you know, and which is sometimes, you know, sometimes the case. If you're dealing with a small shop, you might be doing some of the machining and the welding and everything. You know, you might be a 1 or 2 person operation where you're doing small knockout parts like this instead of, you know, thousands of these where you have, you know, 1 person machining and, you know, you're just knocking out the welding. But yeah, for sure.
Okay.
But that's this piece. And like I said, this piece is definitely a lot more complicated than the other ones that I showed. And you can see that in here. So this is just this. So this first view, if we're gonna take a look at this in SolidWorks. So this first view is a side-on view, but it's cut in half. It's cut down the middle. So if you're looking at it, it would be, oh, seeing they can't do that easily with this. I go essentially like this. They designed it. They designed it kind of 3D. They designed it probably on this plane here. And so when you go to look at the views, you can see that they're based around the flat edges of that bottom flange. And so instead of being 90-degree.
Could you click on one of the like corners and get the side view possibly when you're in the view mode?
It's really hard to, so you can click on stuff and you can go normal to that and see that just flipped me all the way around. So it's,
I was talking about when the cube was around it.
Gotcha.
So when you're in that and you click on the like the corner
that does, yep, you're right. That did give me a straight on view because we're going diagonal, 45-degree to that edge. So yeah, so there's our dead on side view that should match up if it's not flipped. Yeah, we're flipping 90 degrees, but so we zoom around here and click on that corner. There we go. That's that image there. But we'd be doing a cross section, which let me see if I can remember how to do a cross section. I think I have to put a cross section in to then create it. And right off the top of my head, I can't remember how to do that. So we're not going to, don't get to see the cross section view, but essentially this is, it would be, now I'm curious. I kind of want to figure out how to do my cross section view through here. What I could do is I could do hidden lines, which gives you a little bit better idea. And then if we go to that corner there, then you can see the hidden lines through, and that gives it a little bit better idea because you can see the internal geometry of everything. So it's not a true cross section, but you can see where your internal shape would be of this object. Gives you, essentially this idea here. And then this one is going to be straight down from the top. This one is going to be from the threaded end straight on at the threaded end. So if we go back to that piece, we have straight down from the top view, rotated. So we're sitting still on the 45 there, but you get the right idea. And then this one is going to be and this I can do like this and just go normal to there. Is going to be that view. So we're looking at it threaded end pointing towards us, flange out towards the back. And that's this view right here. Does that make sense to everybody?
Yep.
Yep.
All right. And then all of this is just machining call outs for each one of these parts. And you can see the parts are numbered, right? So you have 1 and 1, 2, 2, 4, and 4 is that plate there. So all of these parts are numbered here with the call outs for where they're at in this piece too. So it's, or maybe these are, yeah, that's what we're looking at. So this is giving you the internal dimensions of that hole in the bottom and a whole bunch of other stuff like that too. So yep, kind of a confusing one. Worth taking a look at, but a little bit probably towards the complicated end of things. All right, and then this one is sort of complicated, but not nearly as bad as that other one. It's only got, you're only dealing with stuff that's extruded in kind of one dimension. Or one direction instead of having multiple direction for your extrusions. And so this one looks like that. But if you have problems seeing that as something, let me open up that file. So that one is that. And so to give you an idea, so like this, obviously there's a lot more stuff that could go on in a blueprint. And we see that. So like I didn't make this blueprint, right? So there's a lot more stuff going on here. You have cross sections, tells you what your material is, you know, a ton of other stuff in here. Tells you what your threading is, stuff like that. But with a piece of software like SolidWorks or some of the other ones like Fusion 360, I mean, I was able to make this drawing, you know, in just a few minutes once I had this part. So I was able to import this part into the software and then go from there and, you know, and bring out what is probably a good enough blueprint to replicate this part out of something. You know, you'd have to, it's not good enough to do the machining or things like that. But say if you were trying to then replicate it into some sort of CAD program and 3D print this would be more than enough to do that. It would probably be enough to machine it. You just have to do a little bit of figuring out. There's some things in here that are not included. Say like the height of this centerpiece here, or the height that these ribs hit that centerpiece. So you don't know what this angle is. You also don't know what that gap is. So there's a few dimensions in here that would definitely need to be included in here. You'd probably have to do a cross-sectional drawing to be able to get it so that you could see those heights. So let me open that up and let me show it to you in SolidWorks so that you can kind of get an idea what I'm talking about. So you can see here that these ribs run along a plane. So if you were to do a cross-sectional cut through on this, you'd be able to then label the height, like this height right here. And you'd also be able to label this height right here, which would then give you the angle that this needs to be drawn at. You'd also be able to show what the height of this cylinder is, because you can see that it sits down further in than the height of this piece. So in that drawing that I made, not a great drawing after all. I gave you some dimensions here, but by far there's a few dimensions that are missing. So there would definitely, for this to be an inclusive blueprint, you would have to have a cross-sectional cut through, and that's how I would do it. I would cut it through one of these. I run my plane along the middle of one of these ribs, and then that way you could get all of those other heights. And you know, to keep somebody from having to do the math, though, this would be pretty simple math. Since there's 6 of them and you're going 360 degrees, you could show what the degree separation is too, from, you know, from rib to rib. Though, like I said, that's, since you can see that they're equally separated, it's pretty simple math. But back into the SolidWorks drawing, does that make, so this one, like I said, once again, we had top down view. We had a side view, and then we had a bottom view. The bottom view is kind of necessary on this because it shows that the plate is solid. So we had this bottom view, shows that that's, you know, you have, it's not open up to the flange. And then we had an isometric view. I think I can just, yeah. And so we have an isometric view there too. So that's all of the drawings that I had in there. Does that make sense? Did that help the people who were potentially having problems seeing this and coming up with what the shape actually looked like?
Yeah.
Okay.
I'm honestly, I was kind of getting the hang of it, just having those blueprints to look at too. So I don't know
Okay.
if I'm a good example, but that's SolidWorks looks like a awesome program.
It is. I wish it was less expensive. Though, as a plug, if you guys weren't completely dissatisfied with my class this fall, I do teach SolidWorks in the spring. So if you want to learn how to use that software and at least get it for a time period that you're taking the class, and I think you might get a little bit longer license on it. I do teach that. So, and we might even start looking at doing, though I'll have to teach myself the software, Fusion 360, because I think that's a little bit less expensive. And I think there might be free student licensing for it, which is a bonus. You guys, you could start messing around with that right now. I believe you can download it for
That would
free
be
as a
sick.
student. Yep. And Fusion 360 is very similar to this. And so, and it's neat. I mean, this is the way you can build stuff in here is super fun. And I do a lot of 3D printing, and I design my own pieces and 3D print them using this. So, it's nothing super artistic. It's just useful things. But still nice to be able to be like, I need this plastic part because it broke, and then take a few measurements off of it, design it in the software, export it, and 3D print it. So, which is super nice. So anyway, back to the first, what we're going to have you guys do for your final project. So like I said, would have really liked to have you guys like either have an object in hand and be able to make a print from it or something along those lines. And this is very simple. But I would like you to take this and, create for me a top-down view, a front view, and a side view. I don't know we necessarily need, so this is going to show, these two views are going to be the same. So you can choose how you want it to, how you want to draw that. It doesn't really matter. There's a snapshot of what that view is going to look like. So we're looking for a top-down view, a side view, and a front view. You don't have to do an isometric view unless you're like, if you like drawing things to, with vanishing point type geometric drawings, go for it. This would be a pretty simple one to do. All these lines run to the same vanishing point somewhere over there, and all of these vertical lines run to a vanishing point. I think down is the vanishing down point, but it's so short that you can't really tell. Like I said, you don't have to do this drawing, but I do want a top down front and side, or top down back and side. And so what I did is I saved this software as a EASM file. I'm going to drop that down here. It's this one that's just called Final EASM. And this opens up natively into this eDrawings program. Does somebody want to volunteer to try to install this right now during class to see if you can get eDrawings to install? Without jumping through a bunch of hoops.
I have a Chromebook.
What's it called? I can probably do that.
Sorry, I didn't bring it down here. It's called eDrawings. It's actually made by the same people who do SolidWorks, but this is their free viewing software, kind of like Adobe Reader for Adobe Acrobat. So this is the one that you should just be able to download and install, but I didn't have to do that because it installed when I installed SolidWorks. So I just want to make sure you guys are able to do that.
It looks like it can also be downloaded on Android and iOS.
Okay. I mean, that works too. So yeah, and as long as it's free and as long as it doesn't make you, jump through a ton of hoops, and you guys are fine with that as a class for installing a quick piece of software, what this will allow you to do is then, you know, instead of me sending you still photos, you can actually get in here and you can rotate the piece around and look at it how you want it to draw.
I can't draw it, or I can't download it on a Chromebook.
It will not let you do it in Chromebook.
I just tried and it said it's not compatible.
Okay. Well, damn.
I also
Um,
might be an unfair example because I built my computer from the ground up and it's pretty solid for pretty much everything. So
Gotcha. This, I mean, this should be a pretty light piece of software, but let me see. Let me see if I can try to open this up as something else. So EASM, let's do a quick Google search here. I would assume there's at least one of you guys that has a Mac too. Though SolidWorks should work on a Mac, I think. So nobody's hollering about having a Mac. Sweet. So we might not have to worry about that.
I have a
So-
Mac, but it'll work.
Okay. File. A360 viewer. Like I said, I'm definitely not going to make you buy something either. So, how about for the people that this will work for, if you're fine installing the that software, this e-drawings software, we'll go with that. I didn't see who was saying, who was it who said they had the Chromebook?
That was me.
I have a
Logan?
Chromebook.
Okay,
Yeah.
a few of you guys do. So let's see if you guys, I'll let you download the file and see if there's something that is simple for you guys to be able to download and install for free. Like I said, I don't want you to have to pay for something. If it turns out you have to pay for something, I'll
Okay,
find a
where do
different.
I download the file from?
Let me see here. I will post it. So assignment. I'll upload format. I'll use final. Might as well just make it an exam.
it worked just fine for my computer. So I'm good.
Okay, sweet. So regular Windows users, sounds like it should work. If we run into problems, I can do still photos or still screenshots, and we can go from there. So let me see. Due date, and of course, open immediately. You guys get to see how I can build a. So choose a file. Okay.
So where can I find the software at?
Interesting. So what I might have to do is you should be able to just if you just Google one of you guys just did this. Did you just Google e-drawings?
Yeah, I
Find the
just
software.
I just downloaded or Googled e-drawings and it took me right to the it's like the first link in Google.
Okay. So this is not actually letting me upload this file because it doesn't like the file type. See, so you guys run into this occasion when you have to upload homework. Yeah, I'm running into it now. So I'm going to just save this. This will be our assignment. But what I will do is let me go into, and I'm going to open this up off screen because I need to go into my Google Drive account. The workarounds. Shush, dog. All right. And so oh, we have a folder for you guys. We're going to pop that in there.
Do we want the
so
SolidWorks?
Yeah, so I went to it and I like it made me do these cookie preferences, which is fine. But then it says that I'm for some reason it's saying that I'm eDrawings viewer only.
Yep, that's fine.
Just viewer is fine.
Yeah, it's like I said, it's basically like Adobe Reader. It doesn't let you do any creating or anything like that. It's so that people who have SolidWorks can send out designs to other people to view them. But they
Okay.
can't actually edit them or do anything like that with it.
Oh, okay. All right. Cool.
Looks like my computer's actually downloading the software.
Okay. Yeah, and that's it. It will have you.
You wanted the SolidWorks, right?
No, you don't install SolidWorks. Just install eDrawings. It's by the same people who made SolidWorks, though. So I should be able to share this. Let me get a link. Change anybody who has the link, copy the link. And then I'm going to go to, sorry, we're talking our way through this, but this is going to work. So if I go to email and someone slow computer, I'll select all, then final. And all right. So that should go out to you guys. If one of you guys could test this. Hate to give you guys last week, here's some new software and here's a new file type. Like I just figured this would be the easiest way for you guys to see this piece from all angles, other than me creating a video for it or creating stills, which would also work. And I'm very willing to do that. I can do like a 360 circle around video and some stills if we need to go that route. So did you guys get that link in your email?
Just waiting for it to come in now.
Gotcha. How's everybody else's finals going? I guess you get them next week?
We're just all doing them
Yeah.
this week and next. We'll get this week and next week.
Gotcha. You getting overloaded with them, or is everything pretty simple?
Yeah, it's simple.
Gotcha.
I thought it was pretty cool, actually. I mean, I've done pretty well so far. How about you guys?
Yeah.
So as far as due dates go, I think our last day officially, let me see, because I just created that coursework. Let me see here when it says our
So
last.
it opened up a list of files for me.
Oh, okay. So it gave you a link to that folder. That's fine. There should be one that's called final.easm. Is that there?
No.
All right. What did I share with you?
I ended up getting a file that was that's at the final from 2 weeks ago.
Once you download it, it says final.easm, but when I click on it, it says this file is not supported. I don't know.
Okay, so let me see here. So it looks like what it does is it compiles a bunch of files together into that EASM file type. Let me see if in the folder those files are there. I might have needed to upload other parts with it. Doesn't appear to be that way. Let me try something else then. I'm going to the final zip. And then we're going to go back to the coursework idea for this because I can upload a zip file and I don't know why I didn't think of that. Edit the assignment, instruction files, file, choose file, load, view, cancel. Aha, okay. And this is final. Add file. Okay. Server says it's 0 kilobits. Let's see if it works. And so that assignment should be up right now. We're doing some troubleshooting while we have you guys all online. This is easier than me getting 8 million emails after the fact. Did you guys see that in the assignment?
I got an empty file.
Okay, well, let me try that again because it's possible. I tried to upload it before it was fully zipped. Into here. Move you. Start. Upload again. There we go. That's at least has size now.
Why does it want my company address?
You got to change it to personal use from company.
Oh,
Ah.
it's still muted. Okay.
Just give it your school address if you want. I don't know. The one. Sorry, I was trying to avoid that. Like I said, they don't send me a ton of stuff to bug me if that helps. All right, so somebody try that final project or file now. It should be something with it in there, not just empty.
I'm still getting an empty folder.
Did you?
It says the file is 1 kilobyte, but when I open it to try and extract, it's an empty folder.
Okay. Here's an empty folder. Why are you an empty folder? You shouldn't be. Okay. And nobody was able to get it to work off of pulling it from the Google Drive?
No, I didn't. I wasn't aware of what I needed to click in the Google Drive because there were like 5 different options. So
Gotcha. Download all of them. If you have that, I think it basically with that EASM must be kind of its own little zip version. But let me try this too. We're gonna put a folder here. I'm going to go here and I'm going to close you. So that, put you into that folder. We're going to call you. I'm going to you.
I think I figured out the Google Drive one. So when you open the link in the upper right hand corner, there's the little download tray that you can see there.
Uh-huh.
If you click on that, it should download the file.
Okay.
When you click on the download in Chrome after it's downloaded, it will immediately open it up in the program.
Okay. So that worked then?
Yes.
Okay. Let's try this too. And then zipped it as a folder. So you should be able to extract that folder, and that folder should have that file in there now. If somebody wants to try it from the coursework side of things.
Are the measurements in millimeters?
They are. Everything's in millimeters on that.
Okay.
And the weld bead is a 5 millimeter weld bead. That is not shown in the in the 3D model, but that's what it is. So, and the one on the back. So let's just clarify some things here. So, need to. So there were some problems with how this rendered. Let's consider this one so that it doesn't bulge out. It's just going to be a flat weld there. All right. And then this one is just a straight fillet weld, even though it's shown bulging. Does everybody see that what I'm talking about?
Yeah.
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 It was just the way the symbol showed up here. I just need to mess around with the weldments and SolidWorks. So but you can see here, there's some handiness going on here. If you were paying attention to how I did that in SolidWorks, that might help you in your drawing. So might also be, can I just go? No, it doesn't look like I can do flat view surface like you can. This gets a little wonky. I'm using a mouse to move around in here, rolling in and out on the mouse roller, zooms in and out, pushing the mouse button down lets me pan like this. Let me see if there, no. Trying to figure out how to move left and right. That's not working. Oh, you gotta just do this button. Yeah, you can change your buttons up there. Not all of the speed buttons from SolidWorks work. So, but pushing the button in does let you spin around here. So, all right, was somebody able to download it from the projects on the classroom? Sorry.
I downloaded it. It's still empty, but I also did the other one, and I tried to. I downloaded a couple different apps off of the Google Play Store, and none of them will let you upload that file to it to look at it. So,
Gotcha.
know if it's possible on the Chromebook.
Okay, so if it's not possible on the Chromebook, I'll come up with something slightly different.
Okay.
Let me see here then. So if we close this. Not working. Final zip. Mine's showing up with it there now. So maybe when you downloaded it before, it will, you might, I fixed the nothing being there. It should be there now. When you download it, it should be a folder, and then inside that folder should be the file. But if you are working on a Chromebook and you can't do it, what I will do is I will find a software version or like a file type that I can save that will open up on something free in Chrome, or I will do a handful of screenshots from different angles and upload those. I'll zip those up and put them into a file, if that works. Everybody fine with
Yeah, I
that?
just-
Who's Chromebook users? I don't want you guys to feel like you're kind of coming at this with a disadvantage.
Yeah, I'm fine with that. I also just
Yeah.
tried it again and it's still empty. I just don't think it'll show up on the Chromebook. So
Oh, maybe, okay. Weird.
Yeah.
Chromebooks. So much for being the lighter, more useful computer. Sorry. Did somebody who doesn't have a Chromebook, can you try to unzip the final project? Because there are a few people who aren't in class who might who might need to access this, and I'm just trying to make sure when I do deal with some of the emails back and forth, the easy way to work around this.
I'm working on it, but I'm not the most savvy person, so it's trying. I can tell that it's trying to do something because when I click on the file, it's the icon next to it changes.
Okay.
And then I got the Windows circle going.
I was able to download it fine with the zip as well.
Finished installing that program.
Okay. And Tamara, did you extract it first before trying to open it? I don't know if you need to or not.
I don't, what is it? I don't know what that means.
Okay,
See, I
so-
told you I'm not very savvy.
So if it's a zip file, if we show it in the folder here, my download folder shows up as zip. If you right click on that, you can do extract all.
Oh,
And
okay.
then that opens up a dialog that looks like this, and you choose where you want it to extract it to, and it extracts it, and then you will just have a folder, and then you can go into that folder and you have that file. That's trust me, you are
Oh.
not the first one of my students when I told them they were zip files that they were like, they're what's? So
Well, it shows up in my folder as this, it just shows up in a folder by itself, just like that. It says final, EASF.
okay,
So I don't know if I need to, but let me try it that way.
okay.
Let me go back.
Yes, if you just double click on it, it will show up just like that, but it's still zipped. And some files won't open when they're still zipped.
Okay.
So zipping something basically allows you to take multiple files, put them all together into one file, and in some cases it compresses those files to make them smaller. And I think it all goes back to zip drives. I think it's the compression that zip drives used to use, which look like floppy disks from way back when.
Oh.
Yeah,
You know, I went through storage recently and I found one from high school.
nice.
Yep.
Does that have some D&D stuff on there or something?
No, I was never, maybe if it was David's storage unit, but
Gotcha. So
I
he
was never into
David turned you into a nerd, not the other way around.
Right.
Okay.
Yeah, I might have to ask for his help on this because I did do what you suggested.
Uh-huh. And it's
And
still
it's-
circling at you.
Yep.
Okay. The other option is maybe to open up that e-drawings program, and then from there, go to open and then navigate, like from the piece of software, go to open and then navigate to where you've unzipped that and open it that way. Maybe that will work. no guarantees.
Okay.
So let me see to demonstrate that for people. So let me see, SolidWorks, eDrawings. And of course, my eDrawings program might be slightly different from other people. So if you just open it up, it should look like this. Maybe not without the Pro, I don't know. And if you go to open, and then you can from there. So I just unzip mine into my downloads folder. So if I go to downloads, final, and there it is, and then you click open. And there. So that might fix your problem. I'm not sure. If you're still having problems with it, like I said, I will do my best to take some screenshots that are very good as far as showing what the dimensions are and what the piece looks like. And I will upload those to the project folder as well. So you guys, you shouldn't be at any disadvantage without being able to orbit around it. I was just hoping that we could make something so that you guys could see it, and be able to manipulate the piece a little bit if you were trying to figure out, what your two-dimensional drawing should look like.
So David helped me in a matter of clicks, and I
Oh,
got
okay.
it.
Thanks, David. Yeah.
He said, thank you.
All right. If somebody else doesn't have a David in their life,
Right.
I will be making some pictures too and posting those. Any other questions on this? Like I said, I think I was going in to see when all of that is due. Let me see. It looks like the end of the course is officially the 24th, which is next Wednesday. So if you guys can get stuff turned into me my Wednesday at midnight, I'd appreciate it. I think my last day to turn in grades might be a few days after that. So if for whatever reason something comes up and you can't, please make it something other than, I'm cooking a turkey, because I'm going to be cooking a turkey too. So, that would be ideal. Get it to me turned in by Wednesday at midnight. Also, if you have any outstanding homework assignments, if you just go into your guys's coursework and look through, if there's any that are not graded that you have turned in, holler at me. And if there are any that are not graded that you haven't turned in, turn them in. I will give you a grade. I will give you full credit because I don't care if stuff comes in late, as long as you guys understand how to use, the material that I've been given to you. So, having people turn stuff in on time just as a way for me to manage my time, my workload. It's not, I worry more about you guys understanding how to do, how to read blueprints in this case. So,
Just to clarify,
yes.
because I just spent a lot of time trying to do things while you were talking.
Yes.
You want these different views. Can we, so
Yes.
we just print off of that program? Is that
That would be a way that you could do it. Or you could get the angle from the you could look at it in the software and then you could draw it by hand. It is simple enough that it shouldn't be too terribly hard to draw by hand and put the dimensions in. And that's what I was hoping for, something that was simple enough that you could do it that way. Hell, you can draw it in paint if you want. If that lets you draw circles and squares and rectangles pretty dang easily and put dimensions on them. But yeah, I would like a top-down view. Well, let me get one that is the view I want. I want a top-down view, a front view, and a side view.
okay?
With dimensions put in there. It doesn't have to be dimensions like this. It can just be essentially enough dimensions that somebody could replicate what they're looking at. And there are two welds on that. Simple
two
welds,
welds.
just a fillet weld in the 90 degree and a hopefully. So a fillet weld here in the 90. And this looks like a J weld, but just a butt together flat bevel or flat groove weld in the back.
Okay, got it.
All right.
Thank
And then
you.
we have a hole. Oh. You know, I'm not showing here.
Diameter of the hole.
Yeah, it's not gonna let me do it here. So let me see here. If I go to, that is part 1, and I go to here, and I go to that.
You said top, side, and front view, right?
Yeah.
Yes.
Okay.
So let me here, hold on. Let me just pull this up. I think that was part 1. There we go. So in part 1, we have our extruded cut here. Radius on that hole, or diameter on that hole, is 40. And then it's 50 from the center of that hole to the edge. That part's in the drawing, but the diameter on the hole was not there. All right. Everybody happy?
Yep.
Yes.
Okay. I will, like I said, I will get, I'll get some still shots out so that you can see what's going on. And for those people who don't have the ability to open this up. And by next Wednesday, if you guys have any questions, always just send me an email, and we'll go over it. And you know, I can set up a Zoom meeting, or I can just answer you back on email if it's easy, and we can just go from there. So you guys have a great evening, and I'll talk to you later. And if I don't talk to you by the time class is over, if I don't, you know, other than just an email of, hey, here's my stuff, you guys, you know, have fun in life doing all the fun things that you're planning on doing. So I hope your welding classes went well, and everything else. So, all right.
Awesome.
Have a good
Thank you,
evening.
man.
Awesome. Yeah,
Thank
thank
you
you.
very much.
Thanks.
Have a good night.
You too.
We'll see you.
Yeah. Bye. Hey, we
Bye.
need to go bowling sometime.
I know. Well, your Thursdays were busy, so
Yeah, I know. Are they doing bowling now?
no, nobody's
Yeah,
gone back to bowling. So
I didn't figure.
We talked about it. We want to do it.
we did talk about it. David's back there.
Well, we could just bowl on a weekend. I mean, Morgan and I are both vaccinated. I assume you guys, you know, are, because you're intelligent peoples. So
Yeah, we are for sure.
Yeah.
Everyone we know, as far as I know, is as well. So
yeah, we could even bring Grant and get him drunk. So yeah.
that's not a hard thing to do.
Well, okay, yeah. The tricky part would be bring Grant bowling and keep him sober, right? So
Yes. Yep, that would be the feat.
yeah. All right,
yeah. That sounds fun.
all right, sounds good. I will I'll talk to you guys later then.
Okay, sounds good.
All right, bye.
Bye.